A dial bore gauge. I'm going to show you a simple operation of it. Simple operation. Let's get that focused there real quick. Come on. I guess it's not going to be that simple after all. Here we go. We're getting there. We're getting there. This is just a retractable. The spring just keeps this from rotating. This track keeps this the pin from rotating. It stays within this track. If this was to wear, then this would turn this to, you could rotate this to creating some torque on the geared system here. This is on the pin. There's a gear here. There's a gear right here at this point. This gear is connected to the gear directly behind it. This gold looking gear. This where I'm indicating. There's no spring on that. This gear to the right is connected simply to the gear to this side. They appear to be one-to-one in measurements. Connected to that gear is a coiled spring. That coiled wire. That coiled wire works on the needle. As the needle rotates, as you press this, the needle rotates. That's that spring. If you wanted to know what your if you had backlash, as you push this, you would see this gear turn, and I do have some flex on that. And as I'm flexing just that much, see the gears turn, and you also see the coil spring react. Now it's putting load on that gear, which then is putting load on the gear below. So there's 2 points that accuracy would happen. It's multiple points rather, and one would be where these two gears contact, the backlash between the gears right there, and then the gears down below have backlash. Then we have the coil that can act as can have a delay depending on how sensitive the coil is. Give me a second too. I'm trying to keep the manufacturer from you guys. Put my hand over there like that. But a little bit of loading is creating movement, but it's not transferring to the other side as of immediately. Now the gears are very beautiful gears, and right there is one more gear between the two, and you know that there's another gear between there because both of them would not turn in the same direction. So when I said there's direct, it's indirect. It's one more gear. If they're both turning in the same direction, well then there's another gear to make that happen. So even though and I'll leave this in the video, see the clockwise and clockwise? So that means there's one more gear in there that's probably right below, I can't find it anywhere, it's below this screw here probably, a gear that is interacting with the gear to the right. That's their first interaction. That's being turned clockwise. I'm sorry, this is clockwise. That's being turned counterclockwise, which then turns the other one clockwise again. So the two larger gears you see clockwise. So now there's another point of tolerances that would have to be adhered to. Anything to adjust in here? I don't see a thing to adjust in here. What can wear though? You've got these tracks in here that can wear, or out here. This little piston that would be part of your tolerances. The gear, now we've got another gear. Of course, this can rotate. This is pretty firm though. This is it's pretty firm in there, so that's not going to cause any. That's not a friction issue. And up top here, or also another point of wear that could happen and cause your gauge to go out of alignment. So how would you calibrate this? Well, you wouldn't. You'd send it back to the factory and ask them basically to rebushing it. And also those gears, I don't see them wearing out with this range. There's my total range. Now it's slid down, and I think it's supposed to be right about there. more in line. It feels much more smooth, not being in torque. Torqued being more in line, more parallel with this pin. Well, just thought I'd show you a little bore gauge action. You really are, and your accuracy is just on those gearing. It's no magic. So when you're paying all that extra money, you're paying for the inline, you know, your tolerances between backlashes, literally between backlashes. It's your reaction time, and also the spring being responding immediately. Also, that any turn on this one will automatically reflect in the spring, the coil. So now I release the spring, and you can see that there is no spring inside here. It's just a pin. Now I can check it for backlash again. So as I just check this for tolerances, etc., I'm rotating, attempting to rotate, seeing how nice it is in that glide. I'm feeling no rotation as I put my, nor do I visually see it as I put my little bit of turn, rotation, torque on it, forward and backwards. Not a critical amount. I mean, nothing to cause it to break. Just want to feel if there's any lash in it this direction. So that track is pretty darn tolerant. That's nice. So that's going to square up with that pretty good. And as I do that, you can look at the threads and see if you see the threads rotate at all. I don't see them rotating left nor right, taking on any type of XY. Nothing. That's beautiful. So in conclusion, if you drop this, what will happen? Well, you can see the gears. You can take it apart and look to see if you've got any separation, if things are reacting the same. If you even bent that, you know, is it becoming into, is it getting bound if you bend the tip? There's a carbide tip. Will it change the accuracy? Not at all. It will if your contact point is that critical. The flat surface could change it by that much of however you've worn out the tip. But your distance will stay the same based on your contact point. You would then just simply check it, as I showed you in the previous video, to check your accuracy, your reading. Grab some feeler gauges and check it with the micrometer, and you'll know how accurate you are within tolerances. Again, how much you're off by. You can work with those tolerances on repeatability. So do it 3 times with the same device where you want to be at, the same measurement, 3500 for example, and you'd be okay. Just line that back up. You'll be okay to keep using it. So yeah, it's okay to buy a cheaper version. You can see I'm doing this, and what am I doing? You know, I'm creating heat, things like that on the drive, on the gears, but I don't know what the gears are made on here, but they're going to be okay. The click you hear is there's a rubber bushing here. You hear it? It's right here. You're bottoming out right there. If this rubber bushing would work further down and not up, we wouldn't hear the tap. As you can see, I can do it without it at a great speed. So that clicking now, the noise you hear is right here. The rubber bushing is not actually underneath of there. So that's your tapping noise.